Alright, today guys we're going to talk about mutually exclusive events and probabilities to deal with them. So before we jump into that, let's just review what we did yesterday. So identify the sample space. Remember, sample space is the number of things that we can actually have are our outcomes. So S equals hours of sleep in a day. Well, let's think the least amount we can have is 0. Okay, we could sleep not at all today. It's not likely to happen, but it could happen. And we can go all the way up to 24 hours. It's unlikely to happen, but it's possible. Okay, and we put the hyphen in between because I could do something like 2.5 hours or 2 hours and a few minutes. So that's why I have that hyphen. Now it's selecting our favorite day of the week. So S equals, well, we can be a Monday. We can have Tuesday. And I kind of have a pattern here, so I'm just going to put a dot, 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 since I have a pattern all the way up to Sunday. And that is sample space. Now let's look at probability. So randomly selecting a heart when picking one card from a 52 card deck. Well, there's 13 hearts, so there's be 13 out of 52, okay, which we can reduce to 1/4. Or we can also do a decimal, which is 0.25. Okay, we would accept either reduced fractions or decimals. Alright, now let's get into mutually exclusive. So, mutually exclusive is when two events cannot happen at the same time. So, mutually exclusive events means that they're exclusive, so they cannot happen at the same time. Not mutually exclusive means that they can. Okay? So, a mutually exclusive event would be having math first period and also having choir first period. Okay? I can't pick a student that has both of those classes first period because they're either in one or the other. So that would be mutually exclusive. A not mutually exclusive event would be somebody having on their schedule at some time in the day Algebra 2 and English 11. Okay? Most juniors have both of those, so that's a not mutually exclusive event. Alright, let's look at just determining if these are mutually exclusive or not. So if I roll a die, event A and event B. So this isn't two times I'm rolling the dice. I'm rolling it once and seeing if both of these can happen at the same time or not. Well, rolling a 3 and a 5. Well, if I roll one dice, I can only get a 3 or a 5. So it can't happen. Okay? So this is mutually exclusive. Because it cannot happen at the same time. Okay, so for number 2, randomly selecting a male student and also randomly selecting a nursing student. Well, can we have male nursing students? We sure can. So this can happen at the same time. So this is not mutually exclusive. Okay, I'm kind of shortening it just because for space purposes and time purposes. So if I draw a card, event A is drawing a heart and event B is drawing a 10. Well, is there such thing as a 10 of hearts? There is. So it can happen at the same time, so it's not mutually exclusive. Okay. Now number 4, so drawing a queen and drawing an even numbered card. Well, a queen isn't even, it's a queen. It's its own thing. It's a face card. So this can't happen at the same time, so it's mutually exclusive. So the big thing here is if it can happen at the same time, it's not mutually exclusive. If it can't, it's mutually exclusive. All right, and how mutually exclusive affects probability? We talked about yesterday, if we had two things, if we wanted one or the other to happen, we could just add them together, okay? But if there's sometimes where it can happen at the same time, we are going to have to subtract that part when it can happen at the same time. Another word that we call this is the overlap. So if I'm trying to get two probabilities and I add them together, sometimes we're going to have to subtract the overlap so we don't count them twice. So let's look at an example. What's the probability of drawing a 5 or a 10 from a deck of cards? So if I draw a 5, there's 4 5s out of 52. Okay? And then I'm going to add that. Since it's an OR probability, so OR means add. So then we're going to add 10 out of 52. Well, there's 4 10s in a deck of cards. Okay? Now, is there a 5 and a 10 card that's the same thing? Nope, it's either a 5 or a 10. So we're just going to go ahead and add these. So remember, we add the top. So 8 out of 52. Okay, and then we can reduce that fraction, which gives us 2 over 13, because you can divide them both by 4, or that as a decimal is point, I'll go 3 decimal places, 1, 5, 4. Okay. So what is the probability of drawing a spade or a diamond? Well, the spades are the black ones that kind of look like this, like a reverse raindrop. Okay, and then a diamond, well, they're either one or the other, they're not both. So there's actually 13 out of 52 spades plus 13 out of 52 diamonds. Okay. There is no overlap, so I'm just going to add those together. Well, 26 out of 52. Well, that's half of the card, so that's 1/2, or 0.5. Okay, so I took either of those answers. Now, what is the probability of drawing a heart or a jack? Well, there's 13 hearts out of 52. Okay, plus there's 4 jacks out of 52. Now, there is 1 jack of hearts. Okay, so we're going to subtract, shouldn't have put an equal sign, we're going to subtract that 1 jack of hearts because I counted it twice. I counted it once for the hearts and I counted it once for the jacks. So that's going to give me 17 minus 1 is 16 out of 52. Okay. Then let's go ahead and reduce that fraction. We can divide them both by 4, so that's 13 on the bottom and then 4 on top. Okay, and then if I want that as a decimal, 14 divided by 4 divided by 13 is 0.308 when we round. Okay. Now, what is the probability of drawing a spade or an even numbered card? Okay. So a spade, there's 13 spades out of 52. Okay. And then even numbered cards, well, we have a 2, a 4, a 6, an 8, and a 10. So there's 1, 2, 3, 4, 5 of those. Okay. And then there's 4 of each of those in it. So there's 4 suits. So 5 times 4 is 20. So there's 20 even numbered cards. Okay. So we're going to add those together. But then if you think there is one of those are all spades. So I'm going to have to subtract the 5 that overlapped. Okay. So that would be 33 minus 5, which gives me 28 out of 52. We can divide both of those by 4, so that's 7 over 13. Okay, which then as a decimal, 7 divided by 13 is going to be about 0.538. Okay, so for the big ones, is if there's overlap, we need to subtract them when we do those. All right, X, take it. Go ahead and write this down. So why do we need to subtract that overlap, this probability of A and B happening at the same time when we're finding A or B if they're not mutually exclusive? So why do we need to do that? Why do we need to subtract? Go ahead and write down your answer, and then go ahead and get started on your practice problems.